Hello everyone. This is Dr. K. Revathy, Assistant Professor of Chemistry, Sri Sharda College for Women. Here we are going to discuss about the topic green chemistry, in which specifically we are going to learn about the ultrasound mediated organic reactions. Here, first let us see what is a green chemistry, or otherwise it can be called as clean chemistry or benign chemistry or sustainable chemistry. It is a design of chemical products and process to reduce or eliminates the use of hazardous substances and also the elimination of generating the hazardous substances. The main objective of the green chemistry is to find out the greener approach for the existing less acceptable one, and also to lead a sustainable development. These are all the main objectives of the green chemistry. Here, development means it should meet the need of the present work without compromising the ability of future generations to meet their own needs. And what are the alternative energy resources for performing an chemical reaction is we can perform the organic conversions by using a microwave, ultrasound, mechanical energy, and water mediated reactions, ionic liquid, supercritical carbon dioxide, deep electric solvent, enzymatic reactions, and so on. So we are having n number of alternative energy resources for performing a chemical reactions rather than the simple mode of performing the reaction known as simple by means of heating. So these are all known as alternative energy resources. Why we are calling it as an alternative energy resources? Rather than the conventional heating, these methods of energy resources provides a chemical reaction to complete it in a lesser timer with a more efficient way, and also selective product formation also is possible in these kind of alternative energy resources. Hence, we can call these kind of energy sources as alternative energy resources. And when we performing a reaction by using these sources, we can call it as an green chemistry or sustainable chemistry also. Here, in this video, we are going to see the ultrasound mediated organic conversions. There is some simple reactions we are going to see about it. First, let us learn what is an ultrasound. That is, it can be used as a source for many organic conversions. This ultrasound, the reaction performed due to because of this ultrasound means it is known as sonochemistry. That is, it deals with the effect of ultrasound on a chemical reaction. Here, the sound waves are basically classified into three different ways. The first one is infrasonic waves, whose frequency is found to be less than 20 Hz. It cannot be audible by human ears. And the next one is audible waves, or it can be called as sonic waves. It is audible to human ears. 20 Hz to 20 kilohertz is the frequency. And then the ultrasonic waves. Here, the frequency is found to be greater than the 20 kilohertz. It is inaudible to the human ears. And this kind of ultrasonic waves can be used to determine the depth of the sea, means sonar. Here, let us see the advantages of using this ultrasound irradiation for performing conversions, chemical conversions. Here, the first advantage is found to be the reaction time and the reaction condition, that is, the temperature in which the reaction is performed, is found to be reduced. That is, reaction time as well as the temperature is getting reduced from hours, from days to the minutes. And this ultrasound improves the efficiency as well as the selectivity of a chemical reaction. And here, the solvent-free reactions can also be performed. The reaction workup was found to be very easier one. These are all the advantages of the ultrasound mediated conversions. Now, let us see the generation of ultrasound, how these ultrasound energy waves are generated. By means of two concepts, we can produce the ultrasound. The first one is magnetostriction and then the piezoelectric effect. First one is the magnetostriction. Magnetostriction. It is a property of a ferromagnetic substance cause them to change their dimension during the magnetization. When a ferromagnetic substance is magnetized, its dimension, its shape get changed. That is, when a magnetic field is applied across the length of the ferromagnetic rod, there can be a change in length of the rod. It is called magnetostriction. Because of this magnetostriction, it helps the generation of the ultrasound. So this is the one of the method of producing the ultrasound by means of magnetostriction. The second one is by means of piezoelectric effect. It is an ability of certain materials to generate an electric charge when applied to the mechanical stress. Example for this material is Rockley salt. In ultrasound equipment, piezoelectric material, that is, this kind of Rockley salt converts the electrical energy into rapid mechanical vibrations. So by means of these piezoelectric effect also, we can produce the ultrasound waves for making the reaction efficient in a more efficient way. And let us come to the theory of sonochemistry. For the main theory of this sonochemistry is cavitation theory. What is that cavitation theory? When a pressure is applied over a surface of liquid is decreased. Here, there will be a formation of bubbles. When the pressure is brought back to the normal, the bubble will get collapsed. So, therefore, a lot of changes is taking place within the liquid during the formation of the cavitation. There is a formation of internal local pressure and temperature, which develops and results a shock wave, which results in many physical, chemical, and biological transformation. The shock waves is known as the ultrasound waves, and these ultrasound waves, because of the shock wave, resulting the chemical changes, physical changes, as well as the biological transformation. Now, when coming to the medium of a reaction, that is, in case of homogeneous medium, the shape of the spherical bubble formed should remain same. That is, it is found to be symmetrical in nature. When it is the reaction is carried out in the heterogeneous medium, the cavitation formed in liquid takes place near the solid surface. Here, the nature of collapse changes completely and becomes asymmetric in nature. That is, during the impolation, that is, during the burst of the bubble formed, the shock wave is produced and breaking into the tiny fragments, and further cavitation takes place. And this is the cavitation theory. And this is the bubble dynamics in homogeneous and heterogeneous medium. That is, how the bubble is formed and getting collapsed during the homogeneous medium reaction as well as the heterogeneous medium reaction. This is representing the formation of cavity, and the cavity gets grown. That is, the growth of cavity is shown here. In case of homogeneous medium, the cavity spherical shape is getting retained, and then The high pressure and temperature, because of this growth of cavity in bubble, causes the impolation inwards towards the bubble. That is the collapsing inwards the bubble. In case of heterogeneous medium, it results the formation of an asymmetric collapse. That is, due to the low pressure cavity, it results in a microjet. Because of this internal collapsion, internal impolation, it results in an asymmetric shape formation. It doesn't follow as in case of homogeneous medium. So because of this heterogeneous medium, it creates a microjet, that is an unsymmetrical exploration, impolation of a bubble. This is the bubble dynamics in case of how it can work in homogeneous as well as the heterogeneous media. Now let us see the examples of ultrasound induced organic reactions. The first reaction is a Suzuki reaction. It comes under the coupling reaction. It can be used for the synthesis of biaryl compound by using the reactant aryl boronic acid as well as the aryl halide in presence of water and tetrabutyl ammonium bromide. These reactions can be performed by using ultrasound mediated. And the next example is Sonogashira coupling. And this is a reaction of naphthyl bromide with phenylacetylene in presence of TBAB and a mild base in presence of water. It gives a coupled product between these two reactant. The next thing is Hiyama cross coupling. It is an alkene reaction, alkene generation reaction. Allyl silyl ethers with aryl halide in presence of a palladium acetate. It gives an alkene product. The last one is the Arrete reaction, the formation of an amide from the reaction of aryl cyanide and benzyl alcohol. It is a neat reaction, that is in presence of ultrasound mediation only without any solvent, any catalyst. It is known as the neat reaction. That is just by combining these two reactant in presence of the ultrasound mediation, it gives a product amide. So it is known as a neat reaction. And then here comes the ultrasound mediated some rearrangement reaction examples. The first one is the Beckmann rearrangement. We know Beckmann rearrangement is the conversion of oxime to the amide in presence of a strong acid like PCl5, concentrated sulfuric acid, like that we can use as a catalyst. Here in presence of montmorillonite K10 clay and also by using the ultrasound mediation, we can convert these oximes very easily to the corresponding amide with the same mechanism. And coming to the next example is benzylic acid rearrangement. Here, the benzyl is converted to the corresponding benzylic acid by using the potassium hydroxide in presence of ultrasound waves. And the next example is pinacol-pinacolon rearrangement. This pinacol is getting rearranged to the corresponding pinacolon by using the metal montmorillonite, that is the metal ion impregnated montmorillonite clay in presence of ultrasound irradiation. We can convert these pinacols into pinacolon. Here comes some other examples of ultrasound-induced organic reaction. The first one is the Ullmann biaryl synthesis. That is, these aryl halide in presence of copper as well as the solvent DMF at the sonication condition, it gives the formation of biaryl derivative. Here there is a comparison is given. In case of ordinary heating, the reaction goes up to 2 days, that is the 48 hours. When we are using the sonication reaction, that is the ultrasound mediated reaction, the 48 hours is getting reduced to just 1.5 hours. So this is the reaction efficient. This is the efficient reaction condition. The next example is Wittig reaction, that is the conversion of ketone to an alkene by using a dimethylene iodide. In presence of zinc, as well as the THF as a solvent, in presence of ultrasound, this ketone is converted into a corresponding alkene. The next example is substitution, aromatic, nucleophilic substitution bimolecular reaction. That is, these molecule, this aryl molecule, this chlorine is replaced by an ethoxide group by using a catalyst KOH in presence of ethanol. Here we are using phase transfer catalyst also. Along with that US mediated reaction, the reaction was performed well. And the next example is Baylis-Hillman reaction. It is an adduct forming reaction. That is a reaction between aldehyde with an unsaturated compound, alpha beta unsaturated compound. It gives just an addition product in presence of a base by using DAPCO, diazobicyclooctyl. Okay. In presence of ultrasound mediator, it gives the more efficient reaction product. And then finally, the streaker reaction, the reaction of aldehyde with potassium cyanide and ammonium chloride in presence of methyl cyanide, acetonitrile, it gives the corresponding aminonitriles. Here, as of now, we had seen what is the basic objective of green chemistry and how the ultrasound is produced, the theory of sonochemistry, classification of sound waves, how the cavitation theory helps the formation of a bubble and the impulsion of bubble in which temperature and pressure variation because of that shock wave is produced, and this shock wave is known as the ultrasound. How these ultrasound waves produced is getting varied in homogeneous as well as the heterogeneous medium. These ultrasound waves produced, uh, how it can help the organic reaction conversions we had seen as of now. So let us thank you for observing this video lecture, the patients. Thank you. Thank you so much.